Thank you for everyone for joining today's webinar on alarm management, specifically the philosophy behind an effective alarm management program. We're going to talk about compliance with the two international or the two standards on alarm management, ISA 18.2, which is for the US, and IEC 62682, which is an international version of the standard. First, a little bit about Exida. Formed back in 1999 with an emphasis on process safety, make the world a safer place. We've expanded that role or that view to include alarm management and cybersecurity, acknowledging their impact on creating a safe process and a safe workspace. If you've heard of us before, it's probably because of our work in the area of process safety, certification of devices, SIL certification, so for design of safety instrumented systems, as well as certification of personnel, and with our engineering tools for design of safety instrumented systems. As part of that suite of tools, we also have one called SIL Alarm, which is for alarm rationalization, a topic that we'll discuss a little bit during today's session. So what we're going to cover is the details of creating an alarm philosophy document, why you should have one, what's involved in creating one. We'll take a look at the relevant alarm management standards, and in particular the requirements or selected requirements for what should go into the philosophy, and then we'll look at what are the considerations around those requirements when it comes to determining what should go into your own philosophy, and we'll look at some guidelines and some examples. So first, what is an alarm philosophy? It's really the guide for all of your alarm management activities at a particular site. So it's a document that describes the expectations, the processes and procedures, all related to alarm management, and all related to how you'll follow something called the alarm management lifecycle, which we'll talk about in a bit. So there's many reasons for why one would want to create an alarm philosophy document. It really actually becomes the framework if you want to create a successful and sustainable alarm management program over time, and helps you optimize the performance of your alarm system. So if you're looking to do that, creating an alarm philosophy document, a comprehensive document, is a great first step or one of your first steps. It helps to create a common understanding of alarm management amongst all the key stakeholders in your plant. It'll drive consistency when it comes to work practices around alarm management. It also defines the methodologies to follow related to alarm management to address commonly occurring alarm management issues. Alarm rationalization, which is something that we'll talk about, which relates to determining what alarms are actually justified and needed. There's a lot of things that need to be documented in a philosophy to define the rules for rationalization, so it's an important precursor to that. It's required per both the ISA and IEC standards. If you were audited, having your alarm philosophy and showing how it describes what you do and how that complies with the standard would be something very beneficial if you were to be audited. And the other benefit for creating an alarm philosophy document, if you don't have one now, is it really provides you an opportunity to wipe the slate clean and start over with the way you all do alarm management and kind of setting the vision for doing things in a different, better, more effective way. So with that, let's get started and talk about some of the most common alarm management issues. Whether it's alarm overload, operators are getting too many alarms during steady state or during floods, or whether they're getting nuisance alarms, or they don't know how to respond to alarms. They don't understand the priority of alarms and what they mean, or maybe the alarms haven't been prioritized. All these things get in the way of operators achieving their optimum or maximum performance. And that, in turn, affects the profitability and efficiency of the plant. So having an effective alarm management system is key to help your operators do their job the best that they can. And as I mentioned, one of the best ways is to start with an alarm management philosophy. So let's turn our attention to the documents that define what we should do, the standards and their guidelines. Looking at the history of how that has evolved over time, the first alarm management document was really EMUA 191, which came out in 1999 as a result of the Milford Haven explosion in the UK. That raised awareness to the issues and problems with alarm management and the need to provide solutions. In 2009 in the US, the ISA 18.2 alarm management standard was released. Big difference from EMUA 191, which was just a guideline, so it didn't necessarily have regulatory authority behind it, although it was treated kind of as a standard in some places. But the first true standard was really ISA 18.2 in 2009. After that came out, there was a series of technical reports defined and created by the ISA team, which went into more detail about some of the specific elements out of the alarm standard. The ISA 18.2 standard then was used as the starting point for the creation of an international standard, IEC 62682, which was then just published in October of 2014. The IEC standard really then builds on what was in ISA 18.2, makes some changes, some of which we'll talk about. And now the US standard, the ISA 18.2, every 5 years, standards need to be reviewed and updated. So we're actually in the process of reviewing and updating the ISA 18.2 standard. And what we're starting with as input for changes to that document are the new things that came about in the IEC standard. So hopefully what you can see is that this is an evolving process. Each new standard that comes out builds on what was done with the previous work. In general, we try not to conflict with what was done, but certainly to build upon and add to what was there. And I think you'll find that with the IEC standard, as well as what's coming in the new version of the ISA 18.2 standard. So for this discussion, we will focus primarily on the 2009 version of ISA and the recently released IEC standard. Both define a concept called the alarm management lifecycle, which is the workflow for alarm management. It describes the key activities, the key stages of the alarm management lifecycle, and what happens during each of these, how they work together, how information flows from one activity to the next. Now for this presentation, we're going to focus on the first stage of the lifecycle, which is called philosophy, and how to create that alarm philosophy. It's not necessarily where you always start alarm management activities, but in many cases it either would be the first step or certainly one of the first few steps in developing a program. Now both standards, one of the key elements is to establish a clear understanding of what an alarm is and what an alarm is not. So providing a definition and reinforcing that definition is critical throughout both of those standards. So let's look at what they've defined as the definition for an alarm. It should be an audible and or visible means of indicating to the operator, and I've underlined the word operator to reinforce that for an alarm, the target audience is the operator, not the engineer or the maintenance person or plant management. So everything that goes through the alarm system needs to be understandable and actionable by the operator. Alarm also needs to indicate an equipment malfunction, process deviation, or an abnormal condition. Abnormal underlined because it reinforces the fact that an alarm is supposed to represent an unexpected event, not an expected event. Something needs to be wrong. And last but not least, that it requires a response. One of the major changes, if you call this major, in the IEC version of the standard is the introduction of the word timely into that last portion of the alarm definition. Going forward, it is very likely that that will be adopted in the ISA version as well. So now what you are essentially looking at is the new definition of an alarm. So not only does it require a response by the operator, and I mean not just acknowledging the alarm or silencing the horn, I mean doing something like opening a valve or turning on a pump, something that addresses the situation, that tries to solve the problem. And now add to that that it requires a timely response. So that's the definition. Both documents in Clause 6 define the contents of what is supposed to be contained in an alarm philosophy document. And here you can see a lineup of those different topics. This is just a recommended set. It doesn't necessarily mean that this is the only things that should be included. But you can see that each standard defines for each topic whether it is a required portion of the philosophy document or recommended. If you compare the two standards, ISA 18.2 and IEC, you'll see that the IEC changed some of the recommendations to requirements. So several of the sections went from being recommended to required, references and alarm documentation in particular. Another thing that you might notice is that at the very bottom of the screen, the alarm system audit there's a line item called alarm system audit, and that section or that topic was not contained or not visible in the ISA standard. It has been added to the IEC standard as a required section. That was kind of an oversight, and you'll see going forward in the next version of the ISA standard that that topic will be in there along with probably some additional topics. So let's continue to move on here. One of the next questions might be, how would you structure the alarm philosophy document so that it makes most sense and is most usable by the people that would be reading it? Recommendations that we have are to lay out the sections so that they actually follow the alarm management lifecycle. So alarm management lifecycle has major stages called identification, rationalization, HMI design, for example. That should correspond to a section in your alarm philosophy document. That way you show clear traceability. We also recommend that any of the relevant content would be put in that appropriate life cycle stage. So for example, if you're talking about how to prioritize alarms or what priorities will be used, since prioritization is a task within alarm rationalization, it would likely make most sense for that content to be in that section. So that's what we recommend. In addition, we also recommend making sure that the required and recommended content from that table that we just looked at is also covered explicitly and either worked into the alarm management lifecycle hierarchy or have its own section. We also recommend that you choose your titles of different sections to make it clear what either part of the life cycle or topic from that list they cover. So for example, the list of content defined things such as alarm prioritization, set point determination, and alarm class definition. To maximize the traceability, we would recommend creating specific sections on those topics with the relevant content and putting that in the rationalization section, since that's the life cycle stage where those activities take place. So here's an example from the Exida alarm philosophy template, which will we'll be showing a few examples from, as well as talking about a little bit more. And you can see in this section on rationalization, those categories are called out, as well as above you see that there's a specific section for alarm identification, which is another stage in the life cycle. And above that you see roles and responsibilities. Now, roles and responsibilities doesn't really fall into one of the life cycle stages, but it is a required set of content, so that's why it has its own section in this case, so that there's clear traceability to the information that's supposed to be provided. Now let's move on and look at some of the specific content that's required or recommended in the standard. The very first item that was on the list was defining what the purpose of the alarm system is. And here you can see the guidance that's provided in Clause 6 from both of those standards, basically very consistent in what it says, highlighting the fact that the purpose of the purpose is essentially to help people understand or get on the same page as to what you're trying to accomplish with the alarm system. So one example that we start with or offer as a starting point is this declaration of what the purpose of the alarm system is. So obviously this is not rocket science, but the real goal is to make sure that everybody has kind of that shared vision of what they're trying to accomplish. And a lot of what goes in the alarm philosophy is for the purpose of creating common understanding. Because remember, this is not just for the process control engineer or the guy that's doing the guy or gal that's doing the DCS configuration. This is also for operations, for maintenance, for subcontractors. So there's a lot of people coming in with different preconceived notions of what an alarm is supposed to be or how you do alarm management. So a lot of what goes in your philosophy, its purpose is to get everybody on the same page. Here's an example again from the Exida philosophy template of how we chose to address that, again with the specific example that I showed before. In many cases, folks choose to extend that initial discussion, that initial text, with specific requirements around how the alarm system supports whatever goals they have for safety or reliability and things like that. So that's what we typically recommend as a starting point. Moving on to the next section, there's requirements for definitions. And again, part of the reason this is in here is to make sure that everyone gets a common understanding or arrives at a common understanding of what you're trying to accomplish in regards to the terminology that you're using. So both standards provide a pretty comprehensive set of relevant definitions and acronyms. As part of your philosophy document, I would recommend including those relevant definitions and such in your philosophy. I've seen in some cases where folks use separate documents for terminology and such. I think that takes away from the usability or the ability for the philosophy to stand on its own if you don't have all of the key alarm management definitions included in it. The next topic to discuss is roles and responsibilities. Both standards have requirements for what is supposed to be addressed there. This is a required section. And as part of the required section, there are also four different roles or four different responsibilities or four different tasks that are defined that need to be explicitly called out in your philosophy. So it is important to cover in your philosophy discussion of roles and responsibilities who is considered the owner of the alarm system, the philosophy, and any other related documents, who is responsible for technical support, things like that, all with the idea of helping you to create, again, a framework for a sustainable alarm management program. Now, if you think about how this has been done in the past or how folks might have created their roles and responsibilities without some of that explicit guidance. In the past, it's been very generic, and here's some examples at that. And if you look and you read these, if you are counting on this to help drive an effective work process, I think you're not going to end up with the results that you would be hoping for. So these sets of responsibilities, in my opinion, are not near clear enough or not near specific enough. And it doesn't make sense, it's not beneficial to put something in that's this generic. Part of what you want to do is drive action, accountability, and understanding of who's supposed to do what. And that is utterly critical to make an effective program. So what we recommend doing is first start with a defining of the different key tasks in alarm management. We have those 4 that were defined in the standard. The rest we actually take from experience and from the draft ISA technical report. But you have things in there to a level of granularity, such as if we look at rationalization, we would be defining tasks separately for who's going to participate in the rationalization versus whose job is it to implement the changes. Obviously, that's important to implement, or else you'll never see the results or the benefit from that rationalization. When it comes to training, it talks about who's responsible for developing the training and who's responsible for taking it. Trying to create the full picture to make sure that none of these activities slip through the cracks. And the way that's then addressed is by defining the relevant roles from the plant that would take part in alarm management activities in some way, shape, or form, and indicating their relative involvement, whether they are responsible for the activity, whether they're an approver, whether they support it, whether they're consulted, etc. So we end up with a matrix that defines for each task what the role's relative responsibility is. And that seems to be an effective way to drive that. Next, alarm design principles. Each standard has requirements about what should be included, largely the same. One big difference, though, comes in the importance of this information. The ISA standard takes the last sentence of the first paragraph there and says criteria should be consistent, whereas the IEC standard takes it and changes that statement to shall. So that's essentially a change from a recommendation, which means you should think about doing it, to a shall, which means you need to do it. It's required. One thing that you'll find when you compare the ISA standard to the IEC standard was that there was several areas where recommendations were changed to actually requirements. So what does that mean? Part of what it means is that, or what this section is driving for, is not only to describe what a good alarm is based on the definition that we looked at earlier, but to provide examples and guidance to help you understand what is a valid alarm and what is not. In some cases, examples of things that are not alarms is even more important than putting in examples of what would be an alarm. The idea is to create a clear and understandable set of guidelines to help people uniformly understand what notifications meet the requirements to be an alarm and which ones do not. Another way to handle that discussion is to think about dividing up the notifications that operators get into alarms and other types of notifications such as alerts, prompts, and messages. Now, you don't necessarily have to go forward with definition according to all these different categories, but the idea that you have all these different types of notifications and that they're not all alarms and they shouldn't all be presented to the operator as if they are alarms is pretty important. So then you can consider putting in examples of things that don't meet the criteria for being an alarm, such as prompts or messages, whether just for informational purposes or for expected conditions, so that it's pretty clear when you're going through rationalization, when you find something that doesn't meet the criteria for an alarm, everyone uniformly understands why it shouldn't need to be an alarm or it shouldn't be an alarm. You also want to make sure that you're defining your key design principles in this area of the document. Things like making sure that every alarm has a defined response, what the operator should do, which is a key outcome of rationalization. Making sure that there's sufficient time for the operator to respond to the alarm. And when we mean not too little and not too much either. Remember, the definition of an alarm was changed to include the word timely. So an alarm that the operator has too much time to respond is not a well-designed alarm for various human factors reasons. You also want to make sure alarms, when they're presented to the operator, are useful, relevant, and unique. And in the philosophy, you should describe why that is and what that means. You want to make sure operators don't get more alarms than they can realistically deal with, and make sure everything that comes through the alarm system is prioritized and understandable. So those are some examples of typical design principles that you would want to include in that section. Now moving on to alarm prioritization. Again, very similar requirements in both standards regarding how you should prioritize alarms or what you should do. Typically, basis of the prioritization is on time to respond and severity of the consequences. So now let's look at how to put that into practice. So priority is very important within the alarm system. It's one of the most important elements of an alarm because it helps the operator know the level of urgency or criticality to their response. Primarily from the point of view, if you have multiple alarms present or occurring at the same time, it tells them which one to respond to first. That's what priority does. So there needs to be a means for objectively and consistently coming up with that prioritization. And what's recommended in the standard and what's typically done in industry is to evaluate the priority based on analysis of the severity of the consequences in predefined areas and the amount of time that the operator has available to take the corrective action, where that is measured from the moment the alarm occurs to the last moment in time that the operator can take the action and prevent the consequence from occurring. To make prioritization effective, we want to make sure that there's a small fraction of all the alarms that are a high priority, recommended 5%, with the majority of the alarms being in the lower priority. This helps differentiate those alarms that require more attention by the operator than those that are just one of the pack. Typical prioritization method then uses a matrix similar to this, where we've got our consequences described at the top, and we've got our time to respond buckets at the bottom, and information on how to define the priority inside. Now when we create these consequence matrix, you have to make sure that all of the consequences in a certain column are equivalent. If you look at them, they look like they are equivalent, because essentially alarms that appear that have those same consequences could very likely end up with the same priority, in which case it'll be up to the operator to use their judgment which one to respond to. So in this case, we would look and we would see that in the same column, we have a consequence fatality that's in line with a financial consequence of $500,000. So one could look at that and say that's kind of putting human life, that's kind of putting a value on human life. And in that case, if you look at it from that point of view, it doesn't seem to be consistent. So this would be an example of probably not a good consequence matrix. We also want to make sure that everything that goes in there is pretty explicit and not ambiguous. Words like significant or minor mean different things to different people. The whole idea of creating a matrix like this is so that when you go through prioritization, everybody comes up with the same answers, the same results over and over again. It's a consistent, objective process. And if you're using ambiguous terms as the starting point, that can lead to problems down the road. One place that we would recommend to start in the development of that consequence matrix is from a PHA or risk matrix. Definitely a good starting point. It's got the right kind of things in it. It may need to be modified so that it works acceptably for alarm rationalization, but we always recommend that that be looked at kind of as the starting point. So here's also some examples of how to make those consequence descriptions more explicit to make sure that it's easier for people to come up with when they're evaluating the consequences, what the severity is. The other thing to think about is what are the different time response thresholds for operator response time. And this is dependent on the plant and the process dynamics and what things the operator can do, whether they need to make all their actions from within the control room or whether they have to go outside throughout the plant. You know, so you define 3 or 4 different thresholds, one being, for an example, an immediate response. What does immediate mean in the context of your process to your operator? It may mean up to 5 minutes, and it would mean to the operator that, hey, if you see this alarm come in, you got to drop whatever you're doing and respond immediately, or respond right now. So that's what that conceptually means. So you want to set those time to respond thresholds in a way that they make sense to your operations team and is consistent with the way they would view it. So what we ultimately end up with is a matrix like this, where we've got our consequences, our time to respond buckets, and also our priorities defined within our matrix. In addition to that consequence versus time to respond matrix, not all of your alarms can be prioritized using it, or not all of them should be necessarily. As a governing entity, you can decide or define in this philosophy how you want to prioritize specific sets of alarms. So, for example, alarms that relate to personnel safety, lack of oxygen, gas detection, safety shower activation, H2S detection detectors. Those are common ones where you might say that by definition, any of those alarms are going to be set to the highest priority, just as a rule. No need to go through that priority matrix because that's what's in line and consistent with the way you want your operators to respond. So it makes sense to define then other potential specific scenarios of alarms and how you want those to be prioritized in cases where the consequence versus time to respond matrix may not be easily applicable. So now let's move on to alarm class definition, another topic within the standards that needs to be addressed in your philosophy. So here we see the requirements for alarm class definition, pretty much the same between the IEC standard and the ISA standard except for item L, which was in the ISA standard. So you can see here, though, this is not just defining what classes you're going to have, and we'll talk about in a second how you might go about that, but it talks about that the whole goal for this is to help you manage and administer the alarm system, realizing that not all alarms are created equal. They may have different requirements for training and testing and management of change and audit. So that's really the purpose behind classification, is to group alarms that have common sets of requirements that are different from your run-of-the-mill process alarms. So how might you come up with what your relevant classifications are? There's a couple different ways to do that. One is to think about the different sources, identification sources, that may dictate the need for a potential alarm. So for example, you might have an alarm indicated as a safeguard in a HAZOP, or an independent protection layer in a LOPA analysis, or as part of an environmental permit. The fact that they are described or defined in those documents indicates that they probably have different requirements than your run-of-the-mill process alarm and would require their own classification. And in a lot of cases, you'd set the classification based on how you identified them. Another way to do it is based on the type of consequences. So if it's an environmental consequence or a personnel safety or consequences such as that, or equipment reliability, for example, reduction in equipment reliability, those are other ways to classify alarms, and then also potentially based on where the alarms originate from. If they're uniquely different systems that by their differences would have different requirements, that's another way to potentially do it. So here's a list of some example classifications: personnel protection, environmental protection, equipment reliability, LOPA listed, or it's an independent protection layer. So you can see these kind of illustrate some of the points that we talked about right before this. Now, both standards define a concept called highly managed alarms. And this means that there are certain classifications where you're definitely going to have more stricter requirements than your general process alarms. This was initially created for the ISA standard with OSHA PSM in mind, and if you had an alarm that was part of your OSHA PSM program, your mechanical integrity program, or needed to be there because of OSHA PSM, what are the additional requirements or the specific requirements that it would need to follow as part of that program? So that's where a lot of this originates from. Of course, OSHA PSM does not translate into other countries, but every country has their own regulatory authority or body that has this same kind of idea of differentiating types of alarms and ensuring that they have the specific requirements needed to make sure that they're operational. More on that in a second. As another element of the alarm philosophy, in addition to defining the classifications or coming up with which ones are appropriate, it's also recommended to provide a description of them and any key requirements to make it easier during rationalization so people can look at an alarm and understand how they might assign it to a classification. What does it mean to be a part of a certain class? How do you determine that? And then with the idea that alarm classes are used to differentiate requirement sets, one good way to handle that is through a matrix such as this, where you've got your different alarm classes listed and their associated different requirements for specific areas like training or testing. Now, one thing that we will see in the IEC standard, it's much more strict in pushing that this kind of documentation be provided than the ISA standard. The ISA standard, this was more of a recommendation point of view. This is much more of a requirement in the IEC standard. And going back to the topic of highly managed alarms, any class that you defined, one or more classes, could be designated as highly managed. And if it is, there are specific requirements within both standards that they need to follow. Within the ISA standard, if you designate a certain class as highly managed, you'll find specific explicit requirements around things like shelving and out of service and testing and training. Some people are scared away by that. In fact, there are some people within the alarm management community that recommend staying away from the use of highly managed alarms. I don't necessarily think that's appropriate when you think about what its meaning is or what it's supposed to be used for. So if we think about the gas detector alarms or the lack of oxygen alarms, and if those were considered highly managed, some of these additional requirements that go into things like making sure that if those alarms are shelved or suppressed, that they follow a much stricter authorization and approval process, makes sense when you think about what we're talking about. We're talking about people being safe and not being hurt, and there's lives at stake with making sure that those alarms function as they're supposed to. So the fact that there might be more specific, rigorous requirements around how they are managed makes a lot of sense, and it's only in there to help people differentiate and to make sure that they're doing the best that they can with those types of alarms in terms of ensuring their integrity. Moving on to the next area, alarm system performance monitoring. Both sections or both standards have requirements in that area. Some a little bit different in the IEC standard. Again, we go from a should to a shall when it talks about the specific content, and it adds another line item requirement for guidance on the frequency to how often you review alarm system performance. So the IEC standard is a bit more strict in its requirements and expectations than the ISA standard in this regard. They both define a table of expected KPIs. You'll actually find that some of them are a little bit different. In particular, these up here, where the ISA standard said 150 alarms per day. The IEC standard changed that to say 144, which is the precise calculation if you assume 1 alarm per 10 minutes. So that may result in a bit of confusion to folks, but essentially it's the same meaning of 1 alarm per 10 minutes. For the ISA standard, that was rolled up to be a round number for evaluation purposes of 150. And the IEC standard, that's changed to be more specific in 144. Now, to comply with what both standards really want is to take and make the measurement of those KPIs and the evaluation of them, make that a process that's repeatable and drives action. One way that we recommend to do that is to set up the table of your performance metrics or your targets in this kind of a format, where it shows both a column for target, that's what you're trying to achieve, that would be consistent with the metrics that we just saw, and then an action limit with the idea that any time that the performance is not within the action limit, you're going to take some actions to improve performance. So it's driving action. It also shows the recommended frequency for how often performance should be reviewed. This is an example of how those requirements, particularly from the IEC standard, might be rolled into a philosophy discussion. So here we've got our metrics defined in the format that I mentioned, with a listing of the review frequency. The text above talks about the purpose of why you're doing KPI monitoring and the processes for improving performance and remediation. So this is an example of a way to create a philosophy that meets those requirements, meets the requirements and expectations of what should be defined in this section. We would also recommend that you define what reports, KPI reports or reports that contain the KPIs or help you analyze better what's really going on, that you define that in your alarm philosophy. What do you expect to be created? And then again, with a goal of making this actually work, consider also defining whose role is it to create those reports and whose role is it to review them and propose changes. You want to make sure that you're not just generating data but not doing anything with it. It's got to be part of the process to make sure people are reviewing and taking action. Now moving on to alarm system audit. So this was the topic that we mentioned at the start of this webinar, where there was no requirements defined in the ISA standard for philosophy, but there is in the IEC standard. And as I mentioned, as these standards build on each other, you can expect that the new version of the ISA standard that comes out hopefully later this year in 2015 will also have a section on alarm system audit and its associated requirements for going into the philosophy. So let's take a look at what's there and what that means. So the whole purpose of the alarm system audit is to really maintain the integrity of the alarm system. So you're reviewing your workflow processes and practices, you're assessing performance with operators, interviewing them, and the results might be changes to the design or potentially updates to the alarm philosophy. If you find out that you're not doing what you said you would do, so if you've got a explicit procedure or process for, let's say, management of change or operator training, and as part of the periodic audit, you determine that, hey, we're not really doing this, then either people need to be trained on how things are supposed to be going and behavior modified, or perhaps you find that what you had proposed to do in the philosophy is really not achievable, and the philosophy should, in fact, be updated, which is another point to say that your alarm philosophy is, to some degree, a living document. It will evolve. It will potentially evolve over time as your system changes and as your people change. Another part of the audit is reviewing from the operator's point of view performance. So speaking with them, interviewing them on topics such as, do they know how to respond to the alarms that they get? Are all of the alarm messages understandable to them? This will help you understand how well the alarm system is performing from the point of view of the target audience. The operators are the users of the alarm system. So assessing how things are working from their point of view is a good way to drive continuous improvement. Another recommended part of audit and management of change is to periodically then compare the alarm settings that are in the actual control system in the DCS versus those that are in your master alarm database. Master alarm database is what the results of rationalization, where the results of rationalization are documented. So when you've defined the priority and limit that should be applied for a certain alarm, that information is documented in the master alarm database. So periodically to compare and make sure that those two are synced or consistent is also a part of the audit process. Next, we have, I believe, two or three more topics that we'll go through today. We just picked a few. Certainly to go through all of the different sections and requirements would require a much longer discussion, so we just wanted to pick out a few, go through them. So next we'll talk about alarm rationalization. Definitely an important process that has a significant impact on improving alarm system performance. And you can see that significant change from the IEC point of view is the addition of one more piece of information that's supposed to be documented during rationalization, and that is the probable cause. So as part of your philosophy, we would recommend that you define what your rationalization process is to whatever degree makes sense, And it could be something such as, first you're going to assess the alarm validity, then you're going to evaluate the consequences, then the cause, confirmation and corrective action, and then the operator response time. Also, you want to document if there's any specific requirements related to documenting the information in a specific tool. In this case, we're showing what the SIL alarm tool from Exida, how that would work and capture this information from Rationalization and retain it in that master alarm database concept that I mentioned earlier. So also then within the philosophy, in addition to the process, certain key areas related to rationalization, such as how do you determine whether an alarm is valid and necessary or justified. So here's some recommended criteria that we typically suggest to use. A series of questions that can be asked for each alarm, that if you can't answer yes to the question, then it helps to weed out alarms that don't belong or really shouldn't be an alarm. So questions such as, does it indicate a malfunction, deviation, or abnormal condition? Yes or no. If you can't answer yes to that question, then it probably shouldn't be an alarm. Same for, does it require a timely operator action in order to avoid defined consequences, etc. Again, you see these questions formulated from the concept of what an alarm is supposed to be. So that definition that we looked at earlier helps define the criteria for determining whether something is a valid alarm or should be implemented as an alarm or not. So we definitely recommend putting that into your philosophy document. Also providing guidance on the different ways to consider how you define a cause, a consequence, a corrective action, what's the type of information that you're looking for, what level of documentation do you expect. In particular, we would recommend documenting how to determine the consequence of inaction and what is the consequence that you're looking for in the context of rationalization. And part of the reason why this is really important is because it's a different mindset than the consequence assessment process that's used during process hazard analysis. So certainly want to make sure that folks that do both of those or might come from a safety mindset would understand the difference between the consequence that you're looking to establish during rationalization versus that which used in a PHA. Then there's another section on special alarm design considerations. So the idea is have a section in your philosophy that gathers together specific requirements for certain recurring types of alarms or scenarios. So here's an example, kind of a menu of potential special alarm design categories, different recurring types of alarms within the system and how you want to address their design and implementation from a consistent point of view. And then here's an example of what's defined in the Exida alarm philosophy template. So you've got information about or content about the use of alarms and interlocks and how they should be separated or designed. Also things such as alarming for fire and gas detectors and the expectations and requirements about that. So specific requirements for certain types of alarms. Alarm response procedures. Similar to what we saw with Audit, this topic is not included in either the ISA or IEC list of requirements as it pertains to a philosophy. So it was not in the original ISA, not in IEC, but I expect that it's going to be added to the 2015 version of the ISA standard because this is such an important concept within alarm management. There are other requirements about alarm response procedures within the document, and that's part of the reason why it may be added to content that should be addressed in the philosophy. So here's some of the requirements as they come from different sections in those two standards. So you'll see, and these are pretty important. Alarm response procedures shall be provided to the operator. So this is a requirement to do this. And alarm response procedures shall be readily accessible. Again, a requirement to do this. Now, in terms of what information goes into an alarm response procedure, it's a little bit different between the ISA and the IEC. And just a couple of rudimentary pieces of information. But if you look at what's expected, it's really the information on what's the alarm limit, what's the potential causes of the alarm, what's the likely consequence if you don't respond, what's the expected corrective action, how much time do you have to respond, and what's the alarm class. So all information that we talked about previously is things that are recommended or should be part of this alarm response procedure. So one of the ways to think about this is actually the information that you talk about and document during rationalization. So the creation of an alarm response procedure becomes relatively easy and straightforward if you can do it from the results of rationalization, which is where all that information is defined. So we can do that within SIL-Alarm to create PDF documents. There's also different DCSs that now provide a way to show the alarm response procedures to the operators directly within the HMI. One example here we're showing is Delta V system, their alarm help faceplate, where we can push the information from rationalization directly into that to provide that level of information. Again, here's an example coming from the Exida alarm philosophy template on the requirements and such around use of alarm response procedures. So in addition to the information that goes in it, we also add in the expectations of how the operators are involved in it. So they should be involved in the creation of it, whether it's as participating in the rationalization process or in reviewing these documents before startup or as part of their shift, with the idea that, perhaps they should be familiar with them, before the alarm is commissioned, or to make sure that they're comfortable with those procedures. So the idea is to define not just what goes into the procedure, but how they're used, how the operator interacts with them, and the expectations thereof. In addition to alarm response procedures, there's no specific content in the philosophy on alarm shelving. I also expect that will be changed in the 2015 version of the ISA standard. Shelving or manual suppression is a way for the operator to temporarily remove an alarm from view when it's a nuisance alarm or something like that. So it's a very powerful tool to help them deal or manage alarm upset situations. So as part of the philosophy, you should define how you're going to take advantage or use that function or that process. So considering things like what alarms can be shelved. Maybe it's different depending upon the class of the alarm or the priority. And then what is the process for shelving? Does the operator need authorization? Can they do it on their own cognizance? Do they need to document why they did it? So all of this information needs to go into, or should go into, the philosophy document. Now, shelving itself as a function was a recommended capability for a DCS to have in it in the ISA standard. That was changed to become a required function in the IEC standard. So certainly the push for people to use this functionality and recognition of how important it is only reinforces that you should address this in your philosophy and consider how you're going to use it. So certainly information such as this, not only what alarms can be suppressed or shelved, but also around the procedural use of it. So things like operators should look at a list of all the alarms that are shelved before they start their shift or as part of shift handover. So not just use of this function, but how it works itself into your operational process on a day-to-day basis. So kind of in the home stretch here, I realize that we're running a little bit late here. Just kind of summarizing some of the other things that we talked about here. I've made reference to an Exida alarm philosophy template in a couple of the slides. I just wanted to show a little bit about what that is. That is a generic document that we've created based on the requirements of the different standards, guidelines, technical reports from ISA, from philosophies created by industry leaders. It's essentially a starting point with a boilerplate of recommendations in it that folks can go through and use to create their own tailored philosophy. And we typically use it as part of a workshop. So the idea of creating an alarm philosophy, in case it seems to be a harrowing experience, we certainly provide services to help people do that. And that consists of a training class, a one-day training class, followed by a two-day workshop to essentially walk through those considerations, some of which we just talked about, to come up with what would best make sense for your philosophy. So that's an example of things that we do to help folks create a philosophy document. So now we're reaching the end of our session here. So I wanted to say again, thanks for attending, and we'll open it up for a couple of quick questions. I realize we're over time here, so I appreciate folks hanging on the line. One thing I do want to call your attention to is there are other alarm management webinars. If you enjoyed this one and thought it was valuable, there are others that are posted on the Exida website, including another one that was done previously about how to create an alarm philosophy document. It contains a little bit of a different material and slant than we talked about today. So if you found this useful, I'd encourage you to check that one out as well to get kind of another point of view or set of information related to how to create a philosophy document. So on that note, I'm going to take a look whether there's any questions that can be answered. So there was one question that was submitted in relation to the matrix that I showed, the priority matrix, where I showed in some cases if the operator response time is greater than 30 minutes, what does that mean? I showed it as either being redefined or redesigned. So the question is, what does that really mean? Is that applicable? And generally speaking, as you saw in the new version of the definition of the alarm, it's important to make sure that where possible, alarms require a timely operator action. If significant amount of time is available, let's say 12 hours, you're actually more likely for that alarm to not be responded to than one that requires a timely response. And why could that be? Perhaps the operator looks at it and says, well, because I have 12 hours, I'm just going to leave it for the next shift. And then what happens when the next shift comes in? They don't talk about it or whatever, and next thing you know, that alarm is not being responded to. So that's where the general motivation about potentially redesigning alarm scenarios where too much time is provided, and that could be in the area of adjusting alarm limits and such, but there may be legitimate cases where that's not possible. So looking at that, you might also consider that, hey, if an alarm entails or provides allows significant more time than that, then maybe it shouldn't be an alarm. Maybe it should be treated as something else. It's not really a time-critical situation. So it's all part of what should be looked at on a case-by-case basis. But generally speaking, you want to make sure that operator responses are timely in terms of the corrective action application. So with that, I'm going to say thank you for attending. My email is at the bottom, and I encourage you to attend other webinars in the future. Thank you very much.